Since the end of the 20th century, climate disasters have become increasingly frequent all over the world.
我觉得大自然呢，也确实是已经发出了一些警告，比如说这几年的城市洪涝灾害特别多。
When the ocean attacks the shore, it is the entire coastline which is devastated. The big coastal cities are on the front line of the floods. Regularly, nature wreaks havoc, death, and destruction.
It will happen again, and it will get worse and worse because as the climate changes and the sea rises very slowly but comes up, up, up.
Whether in New York, Shanghai, Tokyo, or Bangkok, floods are the natural disasters which cause the greatest number of deaths. Rich or poor, none of the big cities are spared. What is happening on the planet?
มันก็เหมือนเราใช้ทรัพยากรธรรมชาติมันมากไปไหมอ่ะ
Year after year, cities are becoming increasingly and inexorably vulnerable. Global warming is a cause, but something else is also wrong.
Well, land goes down, subsides, sinks.
The sea is rising, some cities are sinking, and some big cities may need to be abandoned in the future.
What must be done? How can we protect ourselves from the fury of the elements? Is man and his excessive thirst for growth to blame?
Il ne faut pas attendre une catastrophe pour agir. Ce qu'il faut faire, c'est exactement le contraire, c'est-à-dire agir avant la catastrophe.
You have to basically be ready to accept the unpredictable, accept and embrace uncertainty.
All over the world, researchers, engineers, economists, and urban planners are addressing this global threat. Together, they are trying to gain a better understanding of the causes of these floods. They are studying all the potential solutions in their search for answers to ensure a safer future. On the 29th of October 2012, half the population of New York was plunged in darkness and hit by severe flooding. Cyclone Sandy swept down on the east coast of the United States and struck the city with its full force. Streets were flooded, houses wrecked, and tunnels submerged. Short circuits in the electrical systems provoked terrible fires. The Con Edison power plant exploded. The inhabitants of New York, who thought they were safe, found out that their affluent and powerful city was a fragile house of cards.
Back in 2005, I said New York City was going to be flooded. It was not a question of if, but when. Now, I couldn't say exactly when, and nobody else on this planet could say exactly when, but I knew it was going to happen, and it happened.
In the morning, the inhabitants discovered the extent of the damage. Many had lost everything and were not insured. Sandy killed 53 people and caused $19 billion of damage in the state of New York alone.
It's kind of scary. It's like seeing this happen in New York. It's just, you never put your head, you always watch on the news and you never really think it's going to happen anywhere around here. I mean,
it was unbelievable. Well, last night we could look down this street here and we saw the river coming toward us, and it actually looked like something out of a movie.
We are here for you. And we will not forget. We will follow up to make sure that you get all the help that you need until you've rebuilt.
The city had to be rebuilt, but more important was the need to understand. This was what was in the minds of the New Yorkers the morning after. It was not the first time a hurricane hit the American coastline, so why did Sandy cause so much damage?
Every storm is different, and the danger is not understanding where it might hit the land. This is a computer simulation of the hurricane Sandy as it comes up the east coast of the United States. These are the winds. The colors represent the speed of the winds. It's getting bigger and bigger and bigger. Comes up the east coast, over the ocean, then takes a turn to the west and collides with the state of New Jersey, just south of New York City. So this was very, very unusual that a hurricane would suddenly change its mind and turn to the left. And so the winds hitting New York City were very, very strong, even though the middle of the storm was further south.
The wind is not the only cause of such terrible destruction. In the wake of disasters of this type, most of the attention is focused on the movements of the sea and the waves.
The ocean coming up higher, much higher than normal, and washing ashore, going into all the little harbors and all the little rivers, and flooding and finding the vulnerable low places and flooding all around. Also, a second surge came down through the ocean over here, through what's known as Long Island Sound, and came through and pushed through the East River. So we had two surges coming from the northeast and the south, and they converged on New York City, and that's the reason why the surge was so high.
These cresting waves, which used to be referred to as tidal waves, have been filmed by amateur filmmakers and storm hunters. They can provide evidence and help scientists understand the phenomenon.
I remember filming waves, one after another, just crashing over the top of this fence here. Never in 1,000 years did I think I would ever be filming anything like Hurricane Sandy here in my hometown of New York City. Think of one image of Sandy that really stands out in my mind. It would be when the storm surge was coming in at Rockaway Beach. That's a beach that I've been going to since I was a little child. And I was watching it all be destroyed in a matter of hours. Where literally the whole ocean, crashing waves, was just inundating and moving into this entire area. It looked like a tsunami, just this relentless storm surge pouring into the Rockaways.
This huge wave, which Scott calls a tsunami, is in fact referred to by specialists as a storm surge.
I'm often asked, what is the difference between a tsunami and a storm surge? A tsunami is caused by an undersea earthquake. The seafloor vibrates, a big earthquake, and it creates a big wave that travels at very high speed, maybe 700 kilometers an hour. And as it comes close to the land, it gets higher and higher and stronger, and it breaks. And then it shoots inshore and creates a huge amount of destruction and death. That's a tsunami. Storm surge is very different. It's the winds blowing on the surface of the ocean and pushing the surface water against the coast. And then it hits the coast, and then it goes up and up and up. So it's like an extra high tide. It's not a wall of water, but as it goes up and up, it might go over the seawalls, over the beaches, and then it starts heading into land.
By invading the streets, the storm surge caused more damage than the hurricane itself. And at the precise moment it was formed, other parameters increased its power.
What is the stage of the tide when the hurricane hits? And for Sandy, it hit at high tide. But also, there was a full moon. And it just so happened that not only was the tide high, but there was extra high tide due to the moon. And then the storm hit.
The scale of the catastrophe also had to do with timing. A few hours either way, and the impact might have been lesser, or it may have been even greater. And such events reoccur after each storm warning in New York as elsewhere.
Typhoon Haiyan, 6,000 dead.
Cyclone Gorky, 138,000 dead. Hurricane Katrina, 2005.
Typhoon Gorky, 138,000 dead.
After each new disaster, the same question is asked: when will the next one occur?
Memories do fade in people's minds. It's been 10 years since a major hurricane has made landfall in the United States. Hurricane Wilma in 2005 was the last major hurricane. The more time that goes by between storms, the more in danger we are of repeating the same mistakes again. People People's memories fade after a couple of years.
With a changing climate, it could very easily be a 100-year storm. Now, what does that mean? That doesn't mean to say we wait for 100 years for the next storm. It just means every year there is a 1% chance it will happen again. Now, that doesn't sound like very much, but if I was sitting on an airplane at the airport waiting to fly off, and the captain said, there's a 1% chance this plane will crash today, I would get off, right? So the risk actually is quite high.
Well, people are looking for answers. They want to know, is this something that I'm going to have to worry about, more often now?
The people in authority often say, oh, it was a very rare event. It will never happen again. I say, no, no, no. It will happen again, and it will get worse and worse. So we have to plan a long time ahead.
It is no longer possible to hide from the truth. In coastal cities, storm surges have become a major threat. Our societies, with their electronic sensors, computer simulations, and insurance policies, are incapable of defending themselves against such natural hazards. But what will be the scale of the next disaster? Which great cities are vulnerable to flooding, and what makes them so vulnerable? An eminent specialist in the dynamics of coastal regions, Robert Nichols has conducted a major study, the conclusions of which are rather frightening.
So what we did was we actually took a study of all the cities around the world, and we looked at 136 cities that in 2005 had more than 1 million people that were coastal with a port. And we looked at how many people live in the 100-year floodplain. So that's the area that would flood, have a 1% chance of flooding every year. And we found there's 400 million people in 2005 living in these 136 cities, and 40 million, so 10% of them lived in those areas. And we found that certain cities had very large areas in the floodplain. So Shanghai, Bangkok, Jakarta, there were a number of cities that really sort of stood out, and they're mainly actually in Asia.
Robert Nichols' research has led him to a rather surprising conclusion. The fact that so many people live in flood areas is not only due to climate hazards. A new factor has come into the equation.
Some cities, about a quarter of these 136 cities, are actually sinking. And when I say sinks, sometimes it goes down at 10, 20 centimetres per year, or a metre every 5 or 10 years. So these are huge changes. Bangkok is maybe a classical example where the centre of the city has sunk 2 or 3 metres in the 20th century, making it much more prone to flooding.
Situated on the delta of the Chao Phraya River, Bangkok is nicknamed the Venice of the East. Over 2,600 kilometers of navigable waterways crisscross the city, making it particularly vulnerable. The inhabitants have always lived on the water, organizing their activities around the river. But for the last 3 decades, the city has been transfigured by rapid growth, which has contributed to its subsidence. Today, the canals, temples, and traditional dwellings stand side by side with skyscrapers, motorways, and ultra-modern shopping centers in an increasingly chaotic jumble. Since the 1980s, the city's population has grown from 4 to 14 million, an exponential growth that has left Bangkok in a critical situation.
Let's look about 30 years ago. It's okay to use, precipitation or rainwater and store in each house, something like that. But, some pollution coming because the city is getting bigger. So it's difficult to use the rainwater, for supply, for drinking or for use or for daily supply. So people start to rely on, underground water. So when we have over pumping of the underground water, the problems start.
As the groundwater is pumped, the water tables are emptying and the bedrock sinking. At the surface, the ground is also gradually sinking. In the streets of Bangkok, this phenomenon, called subsidence, leaves many traces.
If you see this, evidence of ground subsidence, you can see the barrier is not even. Okay, it's like a wave. Okay, this is because the barrier is not on the foundation, it's in the soil. So every year or 2 years, the Department of Highway have to come here and filling more asphaltic concrete.
All along the motorway, the parapet is sinking where the soil has subsided. And subsidence of the same type is visible in almost all the districts of the city.
So this is the evidence of ground subsidence. Okay, this pier is actually on the pie. So these two areas used to be the same elevation. Okay, but now because of the previous groundwater pumping, so this one is settled. Okay. In some area, the ground subsidence is sunk for about more than 1 meter because it took a long time. Okay, so it's not uniform throughout the area, depending on the where the factory or where they use a lot of water in that area. The bluest one here is the ground elevation of Bangkok that is actually under the seawater because in the past there might be some groundwater pumping a lot.
These areas were particularly affected during the terrible floods that hit Thailand in 2011. That year, the monsoon poured close to 16 billion cubic meters of water into the streets of Bangkok. Entire neighborhoods remained submerged during several months.
People's houses were being damaged, people's cars were being washed away, people's fields were being flooded, agricultural fields on the outskirts of Bangkok. At one point, about 12.5% of the land in Thailand, agricultural land, was underwater.
From the north to the south in Thailand, many rivers flow into the Chao Phraya River. All these mountain waters from the north flow towards Bangkok and into the Gulf of Thailand. Every year during the rainy season, the rivers in flood come close to overflowing, and the capital of the angels thus finds itself at the confluence of dark clouded skies, raging rivers, and stormy seas.
If the three sources of water, we call it three sisters, meet the same time, same place, exactly the right moment, we're in trouble. The first sister is the water from the north, released from the dam. The second water sources come from the sky. It's just rain over the Bangkok. And the water source from the third is the high tide from the ocean. Imagine when the high tide taking place and the water from the north coming down here, it's already almost 2.5 or 3 meters high. And imagine if the rain come in the city, both sides, how could you pump it down?
In Southeast Asia, climate change is also exacerbating the problem. The immutable cycle of the monsoons is being increasingly perturbed.
The patterns of rainfall are changing, they're less predictable. So every year, cities will clear their drains at a certain time of the year because they expect the rain to come at this time. And that's not happening anymore. The rain comes too early, or they clear the drains too late. So when the major rainfall arrives, you suddenly have a flood situation in the city, and the people, the community, the government, they don't know what to do about it.
As the years go by, the risk of flooding increases, whereas Bangkok continues to sink. What is worse is that due to heightened human activity, the city is no longer able to evacuate the excess water.
In the past, Bangkok had networks of canals and natural waterways that would serve as natural drainage, so water flowing from the north through Bangkok to the Gulf of Thailand. With more people and housing, construction, infrastructure, all of those networks of canals and riverways and waterways are pretty much blocked or disappeared.
Look out of the window in Bangkok and look at the construction going on and ask yourself, have these been done with real flood and hydrology models to understand, if you put a building here, what is going to happen to this community in terms of the next time there's a massive rainfall? No, these things are not happening consistently. People are not educated enough. There is not enough awareness of how these patterns are changing, how this 100-year flood might become a 50-year, might become a 10-year, will become a 5-year. Now, we don't have enough information out there within the business community, within government, and within civil society.
Land use plans are partly responsible for the disappearance of the waterways which provided drainage, and disorganized and excessive building work has led to subsidence. Fortunately today, the pumping of groundwater is forbidden in the city, and subsidence in Bangkok has reduced from an average of 10 centimeters to 3 centimeters per year. However, the problem has only been displaced slightly further on.
So the factory essentially moved out, okay, to the suburb, okay, and the factory, some factory moved near the shoreline. It means that the shoreline is subside, okay, creating the intrusion of the seawater inside.
Gradually, the sea gains ground. The coastline of the Gulf of Thailand is eroding. The protected mangrove is disappearing, uprooted by man or destroyed by erosion. In the last 40 years, the water has already advanced 5 kilometers inland. Alone in the middle of the sea, a temple resists against the waters. It is the last vestige of a receding coastline. The village that surrounded it had to retreat, and these electric posts that stick out from the water are the last vestiges of its presence. The men and women who live there have been forced to move several times. Today, 400 of them have moved here, a few kilometers further north. Samon Kansamut, the village chief, is fighting to save her community.
ก็พังมาก็อพยพไปนะครับพังมาก็อพยพไปเพราะว่าแต่พวกเราเนี่ยเราจะไม่ไปไหนเราจะสู้อยู่ตรงเนี้ยเพราะว่าแต่ก่อนเราจะอยู่กับพื้นดินนะคะนอนกับพื้นดินอยู่กับพื้นดินพอน้ำมันสูงขึ้นเราก็จะยกพื้นขึ้นสักศอกหนึ่งสักเมตรหนึ่งแต่ตอนหลังมันหนักเข้าเราก็ยกสูงขึ้นเป็นวานี่คือปรับสภาพที่เราต้องอยู่ไงเราต้องถอยเราต้องล่นนะคะตุ่มมันจมเราก็ต้องหาอะไรมาโถมขึ้นให้มันสูงคือปรับสภาพต้องอยู่กับมันให้ได้ไง
For the villagers threatened by the waters, resisting and fighting back has become an act of remembrance, to ensure their story does not go untold.
อีกประมาณ2 กิโลถึงชายทะเลเพราะว่าเขาต้องไว้เผื่อเนื้อที่ไว้เขาไม่ได้ไปปลูกชายทะเลเด่งเลยนะคะเขาจะเผื่อไว้ค่ะ
The Buddhist temple is fighting its last battle against the sea.
.เรื่องนี้มันเกิดมาประมาณ 3-40 ปีพื้นที่ถูกกัดเซาะเนี่ยสมัยที่เข้ามาอยู่แรกๆยังมีคันดินเป็นถนนเดินออกมามีบ่อกุ้งอยู่หลังวัดปัจจุบันนี้มาอยู่ไม่เท่าไหร่แค่ประมาณ10 กว่าปีนี่ก็หมดแล้วไม่มีอะไรเหลือใช่ไหมคันดินล้มพังก็ต้องทิ้งที่ไปอย่างเงี้ยมันก็เหมือนเราใช้ทรัพยากรธรรมชาติมันมากไปไหมใช่ไหมเราใช้มันแบบไม่ได้สนใจอะไรแล้วใช่ไหมอย่างชายทะเลเงี้ยตามหลักมันต้องเป็นอย่างนี้แต่มันไม่เป็นเรากลับไปทำแบบนี้ถ้าเราปล่อยให้มันเป็นไปตามธรรมชาติอยู่ไปตามธรรมชาติมันการเสียหายมันก็จะไม่เร็วมากขนาดนี้ใช่ไหมมันก็จะมีป่าชายเลน
The temple will inevitably disappear. According to the specialists, if it isn't better protected, it will be submerged within 50 years.
So this temple is a symbolic showing that in the future, okay, there must be a possibility that the water will not stop here. but the water might, going into the city, into the Bangkok area, if we do nothing. So maybe it's time that we think about, protection and doing something about this.
The Gulf of Thailand is just one among many other areas threatened by subsidence and receding coastlines. Out of the 136 major cities most at risk, 30 are likely to undergo major subsidence. But is it possible to fight against this dramatic and irreversible phenomenon? To find out, it is necessary to identify all the parameters involved. In addition to the pumping of groundwater and intensive urbanization, another major factor is involved. Almost all the cities which are subsiding are situated on deltas. The dynamics of the delta regions of the planet is the speciality of American oceanographer James Savitsky.
Deltas are very nice areas to live on for the human population. They're the cradle of our civilization. And they provide nice, rich organic soils, and these organic soils are great to farm. They're also the connection between the ocean transportation and the river transportation. You could go 100 kilometers and the elevation ups and downs would only be a few meters at most. So they're extremely flat. So putting a city on these flatlands is rather easy to do. But now the consequences of this growth are coming back to haunt us. We would put instruments in the rivers, we'd put instruments in the coastal ocean. We would be monitoring how the channels shifted around and all the sediments. We didn't pay too close attention to the human population. We, in fact, never thought it played as large a role as it did. We found that the tide gauges suggested that the deltas were sinking, on average, 4 times faster than the other areas. And so we knew something was up. And so we started to think, humans are doing things. They're making decisions on the ground for economic reasons. So no longer were we looking at a natural system where river and sediment and the ocean energy, but we were looking at one of the biggest players in this story were humans.
Human activity. By building increasingly large cities on deltas, man has made the ground sink faster than elsewhere. But this intense urban growth is spreading far beyond coastal urban centers. In the past, the alluvial soils carried by rivers always settled in the deltas, thus contributing to their equilibrium. But dams have changed all that.
Sometimes when we had dams put in, eventually that sediment was no longer able to get to the coast. It was all being sequestered behind the dams in the reservoirs, and then the shoreline was shifted landward.
Inexorably, the coasts of the deltas in the world are receding everywhere where big cities have developed.
And you see in 1800, there were just a very few dams. And you will see in red where new dams are forming, first in the US, Japan, India. So the issue of dams is very much part of this story.
Today, there are more than 45,000 dams in the world. By controlling the flow of the rivers and by constantly pumping more water from underground, man is gradually spoiling the land upon which he lives and is therefore doubly to blame. Today, new human activities are adding to the problem, such as fish farming, prawn farming, and the installation of industries by the sea. These economic activities do not always take into account the environment.
The cities on the deltas are at risk, all of them. I mean, without question, and they're part of this list of 136 rivers at risk.
As time goes by, the natural balance of the major river ecosystems is being increasingly manipulated and becoming less and less natural. In Tokyo, man's domination of the land has reached a high point. In the 17th century, the authorities diverted the Toni River towards the east, so it would flow into the sea a good distance away from the city. Today, only arms of the river still reach Tokyo. The bay is no longer a delta. Yet, with its 37 million inhabitants, the most populated city in the world is among the most vulnerable to flooding. This is nothing new. For centuries, the inhabitants of Tokyo have regularly endured floods. In addition to diverting the main river, they have dug many canals to limit the floods. This derivation canal, for example, was built over a century ago to protect one of the oldest districts in Tokyo.
Well, the story dates back in 1910. We had a very big typhoon which came up here, and we got a very serious flood. The government of the time decided to excavate this diversion channel so that the city would get rid of the flood. But the area behind the river wall was completely rural.
This farmland should serve as a buffer zone and absorb the floodwaters should the river break its banks. But in the 1930s, people settled here. Huge quantities of groundwater were then pumped, mainly for industry, resulting, as in the case of Bangkok, with the ground sinking by several meters.
The area here is now 2 meters to 3 meters lower than the river water. So the river water level is seemingly reaching the second floor or third floor of these houses. That is a very serious problem that we are facing. We are scratching our head now.
Today, 1,700,000 people live in this district of 120 square kilometers situated below sea level, an area larger than that of a city like Paris, and which represents a fifth of the surface area of central Tokyo.
Here's a pole, and it is showing some signs, and the uppermost sign is saying that the current riverbank level is quite high. And 2 meters above my head, there's a sign saying that the original ground level in 1918 was that. So the current average seawater level is here, which is still higher than me, and now I'm standing on this ground. So this indicates that here is a risk.
Since the 1970s, Japan has forbidden the pumping of underground water in its major cities. But the harm has already been done. Once the ground has subsided, it will never rise back to its original level. Still more worrying is the fact that Tokyo continues to sink today. However, this is due to something completely different. In the Japanese archipelago, earthquakes are extremely frequent. On the surface, they cause considerable damage. But deep underground, they cause another phenomenon geologists and seismologists are well acquainted with: ground liquefaction.
Liquefaction is a phenomenon that occurs in loosely deposited sand. We have loosely deposited sands along the coastline or within man-made reclaimed lands. So we have granular fabric of sand, which is not strong, and the fabric is completely filled up with water.
When there is a big earthquake, the sandy subsoil suddenly loses all resistance and literally liquefies. Under the effect of the pressure, the sand and water rise to the surface, and the buildings sink as if they were in quicksand.
So we will see a huge amount of sand eject, and we want to get rid of
So after removing the sand mass, we see the ground subsidence very clearly.
Everywhere, streets and pavements sink, undermining the foundations of buildings and houses.
Well, you can see here, on all these walls are on a tilt. And you can see here, the original ground level was this. And the subsidence here must have been a couple of 10 centimeters, something like that.
In red, on this map of the Tokyo Bay, are 3 districts which are threatened with liquefaction. The entire port area is concerned.
In this reclaimed area, the ground level is low because it was constructed 100 years ago. And also, there is no countermeasures against liquefaction of the ground. But over this old reclaimed area, there are so many chemical industry factories located in the area.
This industrial area built on reclaimed land on the water's edge is a time bomb. Since the tsunami in 2011 and the accident at the nuclear plant of Fukushima, the Japanese have come to realize that hazards such as earthquakes, tsunamis, liquefaction, and storm surges can combine. And one natural disaster can very quickly trigger off a chain of disasters. In this port area, what would happen if a giant wave swept up these containers and threw them on the chemical plants nearby? Is the city of Tokyo sufficiently prepared?
Tokyo has sunk up to 4 meters in the 20th century. Not the entire city, but the bit of the city built on the delta around the port has gone down up to 4 meters. Osaka in Japan has gone down 3 meters. Tianjin gone down 2 meters. Shanghai has subsided 3 meters. Jakarta in Indonesia has subsided 4 meters and is still subsiding very fast today. Manila, probably a meter. Calcutta and Dhaka, we're not really sure, but they're almost certainly going down. And then places like New Orleans. New Orleans has subsided up to 3 meters and is continuing to subside. Vancouver in Canada, areas there have subsided in excess of a meter. And so all these cities I've named have become much more vulnerable to coastal flooding because of this substance, without any consideration of other changes.
Es gibt noch ein Problem, und das wird wahrscheinlich das gravierendste sein, der Anstieg des Meeresspiegels aufgrund der Klimaerwärmung. Der Meeresspiegel ist bereits etwa 20 Zentimeter gestiegen seit dem 19. Jahrhundert und dieser Anstieg beschleunigt sich und er wird sich auch weiter beschleunigen aufgrund der fortlaufenden globalen Erwärmung.
Stefan Ramsdorff is an oceanographer and a leading climate specialist. For him, the rising sea level is greatly underestimated and will have a colossal impact on coastal cities, especially in Asia, where the rising sea level will be greater because of sea and atmospheric currents.
Warum steigt das Meer? Es gibt 2 Hauptgründe dafür. Einmal dehnt sich das Wasser aus durch die Erwärmung, denn warmes Wasser nimmt etwas mehr Volumen ein. Und zweitens schmelzen die Landeismassen, das heißt die Gletscher in den Gebirgen und die großen Eisschilde in Grönland und der Antarktis. Und das fügt dem Ozean zusätzliches Wasser hinzu.
According to the most pessimistic projections, sea levels could rise by close to a meter before the end of this century.
Als Laie denkt man vielleicht, 1 Meter Meeresspiegelanstieg ist kein Problem, denn wenn man an einem ruhigen Tag irgendwo am Strand steht, die echte Gefahr, die ist natürlich während Sturmfluten. Und eine Sturmflut läuft natürlich höher auf, wenn sie schon 1 Meter höher startet durch den Meeresanspiegel. Es gibt weniger Reibung am Meeresgrund zum Beispiel, wenn das Wasser tiefer ist. Und dadurch steigt die Sturmflutgefahr eben sehr stark an. Wir werden durch den Meeresspiegelanstieg Küstenstädte wahrscheinlich verlieren, weil wir sie nicht verteidigen können.
If we look at the 20th century, in many ways, probably for many cities, the subsidence has been much, much more important than climate-induced sea level rise, because we're talking about meters of change when the sea has risen maybe 17, 20 centimeters in the 20th century. In the 21st century, we expect much more climate-induced sea level rise, and climate-induced sea level rise will affect every coastal city, not just the ones that are subsiding. So we expect sea level rise in the 21st century to be much, much more important than it has been historically.
Subsidence and sea level rise are making things worse in the same direction. So you may solve the problem of energy and global warming, you still have the problem on the land. So these two have independent drivers. They both relate to humans, but they're independent of one another.
Will some big cities disappear in the coming centuries? Will subsidence and climate change bring the rampant urbanization of coastal areas to a stop? In spite of the threat and the uncertainty about the future, urbanization continues at a frantic pace. People flock to the cities, hoping to find work, healthcare, and better schooling for their children. According to statistics, 22% of the world population will live in the major coastal cities in 2050.
More and more people are moving to cities. Globally, now more than half the people live in cities. Human beings being a rural sort of species to being an urban species. We have many more people living in the coastal zone, and with that comes all the buildings and infrastructure, and often that building and development is done without real much thought about flooding.
Situated on the Yangtze Delta, Shanghai is a prime example of this frantic urbanization. With a population of 23 million, the city aims to become the leading financial hub in Asia. And in its ambition to become the symbol of the Chinese dream, it is constantly increasing in size with skyscrapers which keep growing ever higher. But like Bangkok and Tokyo, Shanghai is sinking. In certain parts of the city, because of the pumping of water, it has fallen by 3 meters since 1920. However, the Chinese were the first to study the worrying phenomenon of subsidence. The authorities set up a center to monitor soil subsidence.
这个呢，是我们监测不同深度土层沉降变化的一个监测标组，而且我们目前也已经完全实现了自动化监测的这么一个目的。那我们现在看到的就是地下水位监测井和分层标组的一个监测现场。分层标组呢，可以监测200多米深度的土层的一个沉降变化。
Placed deep in the earth, dozens of sensors measure soil movements in real time.
地面沉降是一种不可逆的，而且是长期客观存在的一种。我们可以看到，是从60年代一直到2010年，不同时期的累积的地面沉降量的一个3维模拟图。可以看到，地面沉降在持续不断的在发展，但是在通过我们采取了地面沉降的一个防治措施以后，地面沉降的一个速率和它的一个变化得到了一个缓解和控制。
Since 1966, pumping from the water tables has been more stringently regulated in Shanghai, but the city continues to sink by 6 millimeters per year. 造成了严重的威胁，同时对我们城市的一个基础设施
造成了严重的一个影响。
According to some specialists, the huge weight of the skyscrapers is partly to blame. The authorities deny this, yet the information is in the statistics published by the Shanghai Subsidence Observation Center. In recent years, with the launching of large-scale urban construction, land subsidence has accelerated.
下一步我们也会针对深基根工程降水引发的地面沉降，开展相应的研究和采取对应的措施。
Meanwhile, many building sites keep being opened in the heart of Shanghai. In a sort of heedless schizophrenia, the city celebrates its modernity by building higher and higher.
上海这几年，可以说30年内，我们从121栋的高层，只有过24米的高层，发展到现在1000多栋，我们最高的已经到692米，我应该觉得是一个骄傲。对上海的愿望，希望它成为世界一流的城市。我曾经到过世界许多城市，我相信上海可以赶上。我自己呢也参与了从几十米做到我们金茂大厦跟美国一起合作的这个超高层的建筑。对于征服这个高层群在上海落地，我们积累了很多的经验，我们完全可以克服这个高楼在这里解决它的沉降，我们可以设计上面就解决，因为上海上面这20米到40米是软的，所以容易沉降。我们是打桩打到很深的60米到100米之间，这种超高层它没有影响到整个上海城市的沉降。
Nothing seems to be able to curb Shanghai's thirst for growth. Not even the threat of climate change, which hangs over the city. Life in the city has always been marked by the taifeng. This word, which terrifies the population, is the Chinese term for the tropical typhoons in the region. The cause of violent winds and torrential rains, they regularly perturb life in the city.
"我觉得对上海来说最难的就是说洪水、潮水、涝水这几种东西都组合在一起的时候，我觉得上海可能还没有准备好，就像前年发生的那个菲特台风，损失很大。最高水位抬高以后呢，就是说市区内的这个涝水也好，还是上游的洪水也好，它就很难通过这个赶潮型的河道排出去，这个对它是最大的一个影响。
Shanghai must contain the many waters that flow into it, such as the floodwaters descending from Lake Taihu, or those brought in by extreme tides, storm surges, torrential rains, and flash floods. Is it possible to protect the city from all these intrusions? Naturally, the first notion that comes to mind is to build walls. All sorts of walls, dikes, barriers, dams, breakwaters, and even floodgates.
这里建了一个挡潮闸呢，就是说是为了黄浦江那个潮水进入这个苏州河，这个苏州河这个闸呢，平时的时候它都是卧在水底下的，这样子不会影响。然后每天大概早晨的时候，它就会开启一下，为了挡这个潮水，
Several barriers against waves have been installed in the center of Shanghai. The 23,000 kilometers of canals and rivers which crisscross the city also have dikes and many floodgates. This line of defense against storm surges and tidal waves reaches far beyond the city limits. For Zhen Wenwei, a researcher and environmental activist, these walls pose many problems.
In the whole China the coast area, they built thousands miles such a dike. On one hand, the government built such a dike to reclaim the wetland for the land, for the agriculture land. On the other hand, this dike is also play such an important role to protect the people from the sea. The wetland is not only protect Shanghai, but also provide the habitat for a lot of species, the bird, the fish. So Shanghai government pay a lot of attention to wetland conservation. They built 2 nature reserves in the Yangtze Estuary area. But we a lot of discussion is where should we protect? Where is our red line? We should protect. If we build too much the dike, they are cost the coastal wetland loss.
If the dikes along the Chinese coast are an environmental disaster, whose interests do they serve? More than 10,000 kilometers of dikes have been built so far, and the construction continues. In some places, a second dike is built to reclaim even more land from the sea, for the profit of property developers. After the Great Wall of China, the country now has a great sea wall. In Thailand also, Bangkok is surrounded by walls, not for protection from the sea, but from the river floods coming from the north. Such barriers pose no major environmental problems, but they can cause hardship. Built in the 80s, the 170-kilometer-long King's Dyke protects the center of town. The inhabitants who used to live on the water's edge now find themselves behind walls, which have been raised several times. But can such a wall resist all floods? What if it broke? Such a dramatic case scenario did take place in Bangkok during the floods in 2011. Under the pressure of the floodwaters, part of the dike gave way. The government had to conduct emergency repairs with 6,000 sandbags. The city centre was saved, but on the other side of the dike, several thousand inhabitants were flooded. The walls still separate people between those who are on the right side and the others, generally the poorest, who are condemned to remain outside the protected area. In this case, the situation lasted 2 months. And as time went by, health conditions became critical, with the stagnant waters becoming contaminated by sewage and dead animals. In 2011, the floods claimed a total of 657 fatalities.
เกี่ยวกับเรื่องที่เศร้าที่แย่เนี่ยก็คือจะเป็นส่วนใหญ่จะเป็นผู้สูงอายุ ผู้สูงอายุเนี่ยจะห่วงบ้านห่วงทรัพย์สินไงจะไม่ไปไหนเลยขนาดลำบากแค่ไหนหรือประเภทว่ายกพื้นอยู่ที่แคร่นะอยู่ที่แคร่เงี้ยแล้วหลังคาเตี้ยแค่นี้เขาก็นอนอยู่
But the people behind the sandbag suffer. They want to take this bag, release the water into the city. So there was some fighting between the two sides of the people.
ของน้ำครับดูความเน่าของน้ำครับแล้วมันมีกลิ่นเหม็นตลอดแล้วชาวบ้านจะอยู่ยังไงครับมีแต่ปกป้องเขตมินบุรีอย่างเดียวกลัวเขตมินบุรีน้ำท่วม
Probably the most striking image I saw were people standing on that wall, where one side of the wall was completely dry, and on the other side of the wall you had entire communities under 1-2 meters of water. And it just exemplified the tension and the challenge. is how do you manage these floods? How do you make decisions on these floods? Whose interests are you going to protect? That wall for me was emblematic of the challenge that we're going to see more and more in the cities, not just in Bangkok, but really across the world.
The impact of floods on poverty and the economy in big cities is the focus of much attention. In Washington, World Bank experts have been working on the problem for several years.
Le problème du lien entre les inondations et la pauvreté, c'est qu'à partir du moment où les pauvres sont plus vulnérables et perdent plus en proportion de ce qu'ils ont que les riches, c'est une machine à augmenter les inégalités. Donc, si vous êtes un petit peu plus pauvre que les autres, vous allez habiter dans une zone un peu plus risquée et vous allez perdre plus souvent ce que vous avez dans les inondations. Et donc, rattraper les plus riches va devenir encore plus difficile.
In our global world, the damages caused by flooding go far beyond the cities directly affected. At the turn of the third millennium, the entire planet is interconnected, for better or for worse.
When Bangkok was facing that severe flood, we realized that this city is not just a Thai city, it is a world city. There was a total economic cost of almost $45 billion because of the floods in late 2011. But perhaps even more striking is that the effect was felt all over the world. The price of hard drives for computers went up by 100% because 50% of hard drives in the world were being produced in and around Bangkok at that point in time. The supply chains were disrupted, about 6,000 roads were affected, one of the major airports was shut down. This is one of the challenges of globalization. It's a very integrated world, and Bangkok is very much part of that global supply chain. And we felt that, not just sitting here in Bangkok, but all over the world.
Beyond the human and material losses, the floods are also a huge drain on the world economy and on the finances of the states concerned. In addition to repairing the damage, they have to absorb the losses incurred by the interruptions to international trade.
Donc, pour une ville, c'est une somme gigantesque aux États-Unis. Si vous pensez à un coût similaire pour une ville d'un pays en voie de développement, ça devient un obstacle majeur. Il suffit de 20 cm de montée du niveau de la mer et de prendre en compte ce mécanisme de subsidence pour avoir des risques d'inondation dans ces grandes villes côtières qui augmentent d'un niveau qui est autour de 6-7 milliards de dollars par an aujourd'hui à des chiffres qui deviennent absolument gigantesques. Donc, dans le scénario qu'on regardait où on ne fait rien du tout, on arrive à des coûts qui montent à 1000 milliards de dollars, mais attention, ce chiffre ne veut pas dire qu'on va en arriver là, parce que c'est un chiffre qui est tellement élevé. Tout ce qui montre, c'est que le scénario où on ne fait rien n'est pas un scénario réaliste.
I think building protection takes time, and that's something that people don't necessarily appreciate. If we look at London, we had a big flood on the east coast of England. London actually wasn't flooded in 1953, but the areas around London were, and it brought home to people that there were great risks of flooding in London. And that led to a process which ultimately led to the Thames Barrier. But the Thames Barrier was opened in 1982. That's 29 years after the 53 flood. So it brings out the point that it takes 20, 30 years sometimes for responses to major flood events. And I think it makes the point that planning for these kinds of issues is a long-term process. It's not something you can turn around one day and do something about and expect an instant result.
Today, the British government has decided to increase the height of the Thames Barrier. Such major works, which take decades to finish, are now being undertaken everywhere in the world. In the Venice Lagoon, for example, a flood protection system has been under construction for more than 10 years. In Japan, this race to build a protective system has reached a high point. The government has invested billions of yen to build walls, install anti-flood barriers, and raise dikes. Over the years, the 116 square kilometers of land around Tokyo Bay have become a fortress.
we constructed dikes and the defense walls and also water gate to protect this inner area. So that in case of emergency, we will close the gate and protect water intruded into this area. This is inner area, and our protection line is here. We are now in the waterway in Tokyo Bay area, and that side is protected part, and we can see water gate. So there are more than 20 important water gates to protect this area.
These protective walls also span many kilometers outside the Japanese capital. In addition, there are gates in the streets, able to isolate the city if the waters rise.
Here is a sliding door for storm surge barrier, and this door will move to this side in case of storm surge, and coming, and here is a road. And road will be closed because on the other side, the gate will come and will close this road. So the people should leave their car outside and then should walk into the safe area.
The inhabitants of Tokyo are regularly called on to take an active part in evacuation exercises. In the Flood Control Center, a team keeps watch around the clock and 7 days a week on the network of floodgates.
了解しました。それでは新大川水門。了解しました。
1号門扉閉鎖いたします。安全確認。外水よし、内水よし。それでは操作に入ります。
新大川水門閉鎖中です。ご注意ください。新大川水門閉鎖中です。ご注意ください。
This impressive system makes it possible to totally isolate the city in case of danger. And consolidation work is constantly being done. But it is underground that the Japanese have hidden their most impressive protection system. Huge cylindrical reservoirs outside the city are connected via kilometers of tunnels which bring the water from the Tokyo suburbs. This underground cathedral is intended to collect the floodwaters. Then, thanks to plain engine turbines, the excess water is gradually emptied into the Edo River.
この施設、平成14年から稼働し始めまして、これまでに91回稼働しております。平均しますと1年間に7回程度稼働している計算になります。
All of these surface and underground protection systems have transformed Tokyo into a stronghold, invulnerable to flooding. Yet even today, the inhabitants remain uneasy. What they fear most is a 5-meter-high wave, which could claim more than 2,000 casualties. New works are therefore planned to raise the walls higher.
On peut très bien imaginer avoir des zones côtières protégées par des murs de 6, 8 mètres, 10 mètres. On sait faire techniquement. La question, c'est est-ce qu'on a vraiment envie de vivre derrière des murs de 6, 8, 10 mètres. Et encore une fois, une protection artificielle, c'est toujours quelque chose qui peut lâcher.
Before 2011 Tohoku tsunami, we believed that it is possible to protect the local residents against the tsunami. But after 2011, we noticed that our power is very limited against the power of nature. We civil engineers now changed our mind that previously we tried to make very strong structures, but we still explain to the residents that in case of very high power of storm surge or tsunami, we should run away we should escape.
Building barricades or fleeing. Neither solution is satisfactory. Isn't this battle against the natural elements one we are bound to lose? And yet humanity has no other choice but to fight against climate hazards. According to a report published by the World Bank, beyond a certain degree of climate change, we shall be incapable of mitigating the effects of global warming and its unimaginable consequences. And it seems the critical threshold beyond which everything is bound to go out of control has been reached.
The history of understanding the problem of global warming goes way back. The first expert report to the United States president warning about the carbon dioxide-induced global warming dates back to 1965. And the basic research warning about the instability of the West Antarctic ice sheet, which leads to sea level rise, comes from the 1970s. And there were very strong warnings back then in the 1970s that this would happen, what we see actually happening now.
It is sad to realize that nature speaks and mankind does not listen, wrote Victor Hugo in 1840. And yet, scientists keep warning us.
Is predicting storms an art or a science? Well, actually, it is both, because weather forecasting, it is a science, but it's not an exact science, because you're predicting things that can happen maybe a week ahead. And there's a certain, what we call chaos in nature that is basically unpredictable.
At Stony Brook University in New York, Malcolm Bauman teaches the art of predicting storms.
Hindcasting is predicting what's already happened. Now you might say, well, that's stupid, right? We know what's happened. Well, the reason we do that is so we can learn that to make our computer models of weather prediction and storm surge predictions more accurate. So we look at historical hurricanes where there is a lot of information being gathered by the Weather Service, by oceanographers, and we can turn back the clock and we can run the computer models to see if they can reproduce that storm that's already happened. And if we can get them right, it gives us confidence. So it's a way of training ourselves and training the computers to do a better job. Now that's quite difficult, and although computer models, weather forecasting models are getting much better, there's still a lot of uncertainty.
Our work is about trying to understand what the future might bring, including the effects of people's choices on that future. So in our work, we can see that if society makes certain choices and chooses certain pathways, things are much better than if it makes other choices. And so I suppose our work is really to try and point out those choices, and I know which way I would go, but at least to make society see the consequences of the decisions it's making and take note.
Faced with such an uncertain future, and to avoid slamming into a brick wall, it seems we need to adopt a different mindset and rethink our protection strategies. In the Netherlands, where people have always lived with the threat of flooding, new concepts have been adopted to prepare for the future. This extremely flat land, with a coastline of more than 500 kilometers, is partly below sea level, and today it is the country in the world with the best defense against floods.
You cannot tell the people of Netherlands to run for the hills. There are no hills, right? And the people of Belgium and France and Germany, they don't want 20 million Dutch refugees, so the Dutch have said, we will fight, and we will hold back the sea as long as we can.
I always like to look back to the maps we drew. We're great map makers in the Netherlands. And if you look at the maps of the 1500s or even the 1100s of the Netherlands, and you would do a cost-benefit analysis on those maps, we all would have moved to France or Germany because it was only water. But we turned that country into a place that actually lives with the water instead of fights it. Building over 3,500 polders, increasing the delta system as an asset, making water safety part of our culture.
Henko Vink is a leading Dutch water expert and one of the spokespersons advocating a completely new philosophy.
How do you live with water? That is the big question. I think that the Dutch found a way by embracing the complexity of water, both threats and assets. It is a key for our economy and our society, but it is also a threat. In the 1100s, we developed our regional water authorities to govern the country in water management. And up till today, we reinvented that governance structure with the Delta program.
During the 20th century, Holland, like other countries, built dikes and dams and huge barriers controlling the flow of the waves along the coast. But the Dutch soon realized that these constructions would only be partially effective in the long term. With the Delta program, the country is seeking to give water its rightful place by trying to cohabit with it by means of barriers and the adapted development of coastal areas.
So that is a change in perspective, not fighting against that water by building higher dams and higher dikes and, making more land out of the water. You have to come up with projects and proposals that are in line with nature, not fighting it.
This change of mindset is the key to limiting future disasters. But there needs to be a commitment from the highest levels of government. Are world leaders ready for such a commitment?
Le problème, quand on regarde la façon dont politiquement les choses se passent dans les pays, en général, les grandes transformations des réglementations ou bien les grands investissements de protection se passent après une catastrophe. Mais c'est un peu le problème qu'on a aujourd'hui, c'est-à-dire qu'on aimerait sortir de ce cycle dans lequel on a besoin d'une catastrophe pour mobiliser l'action publique.
I mean, it's human nature to hope that the bad things will not happen while we are there, while we're in charge. And the politicians, just like anybody else, just hopes that, keep fingers crossed, that it will happen later on when they are no longer in power, when they are safely retired from their positions.
Who is this governance group of people that are deciding that it's okay to have 5 million, 10 million, 20 million people living on a delta and not adequately protecting that delta?
Il ne faut pas attendre une catastrophe pour agir. Ce qu'il faut faire, c'est exactement le contraire, c'est-à-dire agir avant la catastrophe.
If we had a sealed document like a will or a time capsule that was closed for 50 years and then opened, and the next generations look at it, they will say, look, we had a huge catastrophe and we failed to take it seriously and we did not do enough to protect the future generations. And so there would be a lot of wondering why we were so slow.
In Hamburg in Germany, the authorities realized that the political will to act is indispensable for protecting the city against the storm surges from the North Sea. In the area around the port, the government has launched the biggest urban development project in Europe, Hafen City. The principle behind it is to build a new district with shops, housing and office space where there used to be port warehouses. This new district is in the heart of a flood zone, but it is architecturally designed to cope with flood risks thanks to an innovative topography.
Wie haben wir diese zwei topografischen Ebenen in der Hafen City entwickelt? Auf der Ebene von 5 Metern über normal Null, das ist die ehemalige Hafenebene, haben wir den Zugang und die Möglichkeit für Besucher und Bewohner der Hafen City gelassen, sich zum Beispiel um die Hafenbecken herum zu bewegen. In dem Bereich, auf dem wir jetzt stehen, entstehen natürlich die Gebäude und die hochwassersichere Infrastruktur wie Straßen und U-Bahn. Und damit ist der gesamte Kern der Hafen City geschützt vor Hochwasser.
In Hafen City, the concept of pilings has been adopted. The buildings and infrastructures which need to be protected against flooding are raised on platforms 5 meters up, whereas the lower sections are composed of squares, promenades and parking lots, which can be sealed off from the waters. In 2013, when Hamburg was hit by a flood, the system proved effective, the first buildings and inhabitants of Hafen City were not affected by the flooding.
Wird hier in der Hafen City kollektiv eine Vorausschau für die nächsten 100 oder 200 Jahre entwickelt und mit diesem System gemeinsam zwischen privaten Investoren und der öffentlichen Hand hergestellt. Das Konzept der Hafen City ist international ein großes Unikat, weil erstmalig weltweit eine Verknüpfung zwischen Wasserflächen und Stadtentwicklung auf einem risikoarmen Niveau hergestellt wird und gleichzeitig die Qualität des urbanen Stadtraums gesteigert wird.
By 2025, Hafen City should provide housing for 12,000 people and 40,000 jobs along the 10 kilometers of its redeveloped docklands. This ambitious project is a possible answer for the future development of major coastal cities. But how can existing cities be protected from the rising waters? Putting the entire city of New York on pilings is unthinkable. Yet the city is on the list of the 136 world cities most vulnerable to flooding. New York and its 8.5 million inhabitants is literally sitting on the ocean. It is not protected. After Hurricane Sandy in 2012, the United States launched an innovative prevention program. To ensure the success of this ambitious project, the American government called on the Special Envoy for Water Affairs of the Netherlands, Henk Ovink.
This city is a place where the world comes together. In that sense, it's also a city that is a mirror to the world. And that made Hurricane Sandy so important. That is exactly what President Obama captured when he said, we have to ensure that the rebuilding after Sandy in New York becomes an example for the world.
If you look ahead, what should you do? Never use Sandy or Irene or Katrina as a reference to what you're doing. You have to use the future as a reference. That means, by standard, that you have to innovate, that you have to capture new ideas, new science, new ways of financing and governance to actually rethink, reinvent, and rebuild this region really better. And that will increase resiliency.
Urban resilience. This is the new guiding concept in the approach adopted by Henk Ovink and the New York authorities.
Our vision for resiliency is that our neighborhoods, our economy, our essential public services are ready to withstand and emerge stronger from both the impacts of climate change and other 21st century threats. And it's the linkage of those two things. It's the reduced impacts and it's the quicker recovery times that really encompass what we mean by resiliency here in New York City. Our floodplains are expanding due to sea level rise, and the federal government has been mapping New York City's floodplain and showing an expansion from what was 200,000 people living in the floodplain to now 400,000 people and growing. And so we are working to educate people on that risk and what they need to do to prepare for that risk, including how to mitigate it through flood insurance.
Resiliency is not only about our infrastructure or our buildings. Resiliency is really about human beings. That's what I find so important about the learning capacity. It is really a cultural, social, and physical thing. And that makes resiliency a comprehensive way in dealing with future risks and uncertainties. That's why it can be a very powerful way moving forward.
Resilience is a notion borrowed from mechanical engineering and which has been applied to ecology and psychology. The term refers to the capacity of a system or living being to absorb a shock and resume its initial functions.
Urban resilience is the ability of a city not just to bounce back, but in fact to thrive and grow in the face of both acute events, which we call shocks, and chronic events that we call stresses.
In New York, This philosophy is embodied by the Rebuild by Design project. Launched in 2013 under the direction of Henk Ovink, it is the biggest international urban design competition ever organized in New York. It may transform the New York coastline forever. To redesign the future, Ovink brought all the stakeholders together. Mayors, architects, engineers, urban planners, energy grid specialists, and of course, the residents, who are most concerned.
We invested months in collaborating with hundreds of organizations, thousands of people, selecting 10 interdisciplinary, world-talented teams that worked in the region to only do research, to capture the region's vulnerabilities and interdependencies. Also capture the stories, the experiences of all the people that were hit hard by Sandy. And out of that research, a real regional understanding emerged.
Rebuild by Design takes a collaborative approach and says we need to look at regions. We need to, instead of just taking the individual approach, we need to look at regions and give, work towards comprehensive solutions.
We actually don't know exactly yet what the right thing for the Lower East Side is. But when we talk about new uses, we really want to hear from the community here.
We've asked people what are their concerns, what are their demands, what are their dreams for their waterfront, and try to see if we can take the necessity and the utility of flood protection and combine it with the dreams and the desires of the local community.
For me, what I don't want to see is walls in the landscape. I don't want to see people cut off from the landscape anymore. We've done that for 200 years.
Instead of just doing it like a deadpan wall that literally becomes a segregation between the life of the city and the water around it, try to see if can we achieve the same geometry, the same elevation in many different profiles. So sometimes it becomes seating, sometimes it becomes landscaping, sometimes you can occupy, it's a space inside it, sometimes it's a pavilion that can turn.
So we need a different ideology of engagement with the natural world. One that is not about controlling and one that is not about blocking, but one that is about increasing perception, increasing active engagement, and essentially stewardship of our landscape.
The Rebuild by Design project inspired so much interest that the organizers themselves were surprised. All in all, 148 projects from 12 countries were presented. Finally, the 6 best projects were selected and awarded funding of $1 billion. The first among these projects, Living Breakwaters, concerns a vast residential area in Staten Island. The defense measures deployed will be based on recreating naturally protective ecosystems and the introduction of 1 billion oysters.
And what's different about the approach is that we have both a combination of onshore and offshore strategies, the reef and the dune, and together they reduce wave action, prevent erosion, and then essentially rebuild the shoreline. So rather than a conventional breakwater, which is just one size of a unit of rock piled up in a very uniform section, we have what we call reef streets, which are this kind of crenellated pattern where the reef streets are lined with this low pH ecological concrete, and these units are devised and designed specifically as finfish habitats.
The second project concerns the peninsula of Manhattan. The Big U, as it is called, will be an invisible wall 16 kilometers long. It will protect the buildings and once again provide the inhabitants of New York with access to the waterfront, with public spaces and recreational areas.
The idea of the Big U is basically to try to do all of the necessary flood protection of Lower Manhattan. The dry line is almost like an urban chameleon, that it changes character and appearance depending on what neighborhood it goes through. Sometimes it occupies the space under the elevated highway and turns it into pavilions or tipping platforms. Other times it's almost like a giant bench, and at other times it's part of the landscape that races and actually protects the park on the waterfront from the noise of the highway, but also protects the city from flooding. There'll only be parks and pavilions, but secretly inside this there is the necessary flood protection, but there will never be a wall.
In the neighboring state of New Jersey, the small town of Hoboken is the third prize winner. Sitting on the River Hudson, it is often flooded when it rains. The project includes $230 million worth of redevelopment work. The sewers and drainage systems will be separated and redesigned. The objective is to limit health hazards by avoiding the resurgence of contaminated waters in the case of flooding.
So working together in a full circle, resisting as much as possible, delaying it, storing it, and discharging the water. So I do believe that once we get this implemented, we can protect our city. There's resiliency, but then you also have to make tough decisions. And here in Hoboken, I am making the tough decisions, and we passed legislation that says, no, you cannot develop on our piers. You cannot develop on our waterfront. We are not going to put future residents in harm's way by building out on our waterfront.
Renewable design was a collaborative force. We tried to work with everybody, but that also means that you have to start with a process that is like a safe place for all those different groups.
Consultation with the inhabitants was particularly useful for another prize-winning project on the Hunts Point Peninsula in the Bronx. This district is an essential hub for the food supply chain to New York and a good part of New Jersey. But it also has the poorest population in the United States. The works providing protection must also serve to fight against unemployment and help improve the standard of living of this community, whose children have the highest asthma rate because of the constant traffic of refrigerated trucks in the area.
We're very vulnerable, and projects like the Hunts Point Lifelines helps us not only address flood protection through infrastructure, but it also helps us to figure out how to tackle other issues like poverty through connecting that with creating living wage jobs and careers associated with resiliency.
If folks on the ground that are impacted the most, if they're not a part of the conversation on how we need to prepare and respond as a community and a society, then the solutions coming from the top aren't gonna work.
These programs include improvements to the living environment, flood protection systems based on the intrinsic qualities of the natural environment, and invisible walls transformed into recreational spaces. All these projects are already being implemented. Thanks to them and others which will follow, a new vision for the preservation of our cities is materializing. In New York, urban resilience is seen as an ideal solution providing improved protection. But will this be enough? Can it be replicated in other less affluent cities such as Manila, Bangkok, or Dhaka? It seems there isn't yet a consensus in favor of this approach.
Resilience is not enough. I say that resilience is needed, but it's not sufficient. It's not protection.
Being resilient is back to you recover and then you're back to where you were before disturbance.
We need to agree what resilience means, and I think there's a danger that people will all sign up to resilience and they actually mean different things.
Resilience is not just about building hard infrastructure and building protective walls, but it's about changing the mindset of citizens, changing the way governments and people who manage cities think about the future.
In spite of the controversy, the focus today is on the notion of resilience. It recently inspired a vast project called 100 Resilient Cities, which was launched in 2013 by the Rockefeller Foundation. The principle? A network of cities able to share solutions for an improved integration of environmental, economic, and social factors to address the unpredictable challenges of the future.
So the 100 Resilient Cities is, I think, a very exciting effort to actually change the paradigm. Now that is saying all cities, whether rich, poor, large, small, they need to be thinking about resilience in a new way, not just to climate change, but also to things like economic shocks. If you think about a city of 2 or 3 million that in a few years is going to be 4 or 5 million, that means they're making choices now about the infrastructure, about land use, about how communities are being situated, and we can bring the knowledge in through all of these different efforts around building resilience, that's where I think we can actually make a huge impact.
There are limits to what we can do, but nonetheless, within those limits, we have quite a lot of choices if we are proactive and we start planning today. That's the key message. These problems are foreseeable. We can foresee all the issues that we need to deal with in the 21st century now.
Faced with the threat of floods, the big coastal cities of the world have reached a turning point in their history. If action is not taken, in their downfall, these cities could jeopardize a substantial part of our lives. Shouldn't the paradoxes in the governance of our societies be radically called into question? By smothering nature in concrete, we are destroying the incredible resilience of natural ecosystems, and at the same time, we expect our cities to make up for this by becoming resilient. We have turned the world upside down.